You guys know that modules 4 and 5 are pushed out. Module 5 only has 2 assignments in it. Module 4 has assignment 4.4 and 4.5. 4.4 is the poster that you're supposed to create. And you guys have the rubric of everything that you need to have on that poster. Just want to remind you, it does not have to be a huge poster, right? It could be on an 8.5 by 11 piece of paper. You got colored pencils in the book bag that they gave you when you went and picked it up. You've got highlighters and markers and stuff. So I'd like you to make a poster. In that poster, we're going to do explain everything from module 4. We've already talked about the 3 phases of matter, right? Matter is everything that makes matter is what everything is made of in the universe, right? And matter comes as a solid, a liquid, a gas. We talked about plasma. You'll read a little bit about plasma and you'll read a little bit about BE condensates, but we're not going to worry about those right now. We're just going to focus on solids, liquid, gases, okay? And what happens between the phases. So when a solid has thermal energy added to it, my allergies, has thermal energy added to it, what's going to happen is that solid is going to, once it reaches a certain temperature, is going to start to melt, right? So that will eventually turn it into a liquid. When thermal energy is added to that liquid, eventually what's going to happen is that thermal energy is going to start turning that liquid into a gas, right? And we talked about an ice cube going into water, going into vapor, water vapor, right? So the ice cube then turns into a gas, water vapor, which goes up into the atmosphere. If the atmosphere gets too full, or when the atmosphere gets too full of water, what happens? Type in the chat when the atmosphere gets too full of that water vapor. If we're just talking about water vapor right now as the gas. Yes, good. Okay, Nash. Yes, that's a form of. So Abraham wrote in the chat that precipitation takes place. And I like that word because with precipitation, Nash, it means rain, like you said, but it also means sleet, snow, hail. So there's all different types of precipitation that can take place. Yes. Because what happens is that vapor condenses in the cloud and then it has to go somewhere and it's going to fall, right? So think of it like this. If I have a pot with ice cubes in it, I add some heat, eventually it's going to get to the point where it's going to melt, right? And it's going to become a liquid. That liquid water, again, is going to, when you have heat added to it, thermal temperature added to it, it is going to cause that water to become a vapor. If I take a lid and I put it on top of my pot, that steam or that water vapor that is going up is going to hit the lid. And when it hits the lid, because the lid is a different temperature, it causes that vapor to condense again and create those water droplets, right? So now we talked about evaporation, we talked about condensation, melting, boiling, solids, liquid, gases, and lastly is sublimation. And sublimation is when we go from one phase to another, but you skip a phase in between. And we talked about what actually does that. Tell me in the chat what we talked about that goes through the process of sublimation. Yes, good. Okay, so good, guys, excellent. So dry ice goes through the process of sublimation, which means it starts as a solid and it's going to skip the phase of liquid and it's going to go directly into a gas, right? Now, let's try to remember, you guys watched a little video. I thought it was a cute video. I mean, I don't know if I want to use the word cute, but I thought it was an entertaining video in which there was a teacher who had a bunch of her students in a gymnasium. And she kept calling out different things to her students. So when she said, you know, that you are a solid, all the students huddled together, tightly packed and they just vibrated in place, right? And then she said, "Up, you're melting." And when they were melting, they were moving a little bit further away from each other and moving just a little bit more. Then when she said you were a liquid, they were able to walk past one another, right? They weren't moving quickly yet. They were moving quicker than they were as a solid, but they weren't like just bouncing off of one another crazy, right? So we went from a solid and then we melted to a liquid, and then evaporation was taking place. And what happened with evaporation is those molecules started to move further apart and a little bit more quickly. And then when evaporation was done, when it became a gas, those students were just running around the gym, bouncing off of one another, just like gas molecules do. Gas molecules need a lot of space, okay, because they're constantly moving, but they just like solids are, but they are moving rapidly, and they want to get out of a closed container and into an area where there is more space for them. That's the goal of a gas is to not be tightly packed together. So those things you're going to put on your poster. Now your poster is module 4.4. And I made the poster due by Friday. However, I gave you an extension until Wednesday, October 21st. You still have to finish the poster before you can go on to module 4.5, which is the quiz. But this way, 4.4 is not due until next Wednesday per se. 4.5 I also put for October 21st, because you have to have, as I made the module, you have to go through sequentially. You have to have 4.4 done before you could do 4.5. I gave you a little bit more time because you're making a poster, right? I do not want you on the poster I don't want you to create a digital poster, right? I don't want you to go into Google Slides. I want you to actually physically make a poster, because people learn in different ways, and I try to incorporate that in my lessons. And some people learn better if they write out a definition. It sticks in their head a little bit more. So I'd like you to create a poster, take a picture of it, upload that file, and then you can move on to 4.5, which is the quiz. After that, there are only 2 assignments in module 5. And those assignments in module 5 have to do with the periodic table of elements. And we've talked a lot about the periodic table of elements, and we'll start talking about it more again next week. Today, we're going to focus on sublimation. We're going to focus on a Kahoot that I've made for you guys, and any questions that you might have. Okay, so this is going to be fun. I went to the store this morning. I was up already, and I had in my classroom these. Does anybody know what these are? Type in the chat if you've ever seen one of these. I don't know if you've ever seen one of these. Tajay says no. Alexa says no. Of course you guys don't know. Of course you guys don't know what it is. Okay, so Maria, not too long ago, cameras were not digital. And there was something called film that you would put in a camera, and you take that film to the store, and then they would develop it at the store for you. And you got the picture, you got whatever picture you took is the picture you got. If it was a bad picture and your hand was over it, you still got that picture. Okay. It wasn't like a digital file where you could just erase it. So you'd buy film, you'd load your camera with film, you'd take as many pictures that were in the roll. Some of the rolls had 36 pictures, some had 24 pictures. You'd finish the roll of the film, you take it to the store, they would develop it, and then you would have your pictures. Yeah. The film came in these film canisters. The lids for these film canisters, they pop on. Okay. They don't screw on, they just pop on. They're not the same thing as a pill bottle from CVS. And I'm telling you this because if you want to try this at home, you can't use anything with a screw on lid. You need to have a lid that just pops on. Okay, so here are my film canisters. And I went to the store this morning and I actually got dry ice because I wanted to show you how this works. So dry ice, like we've said, is solid, but over a period of time, and look, I am not touching it. I'm taking my dry ice and I am going to put it into my film canister. Okay, I've not put a lid on it yet. If you're going to store dry ice, you want to store it in a cooler. It does not go in your freezer at home. You store it in a cooler. If you store it in your freezer, what does dry ice turn into over a period of time? Type in the chat. What does it what does it turn into? What does dry ice turn into over a period of time? Carbon dioxide, which is a gas, right? So gases, like I said, need a lot of space, and you don't want those gases in a closed in area like a freezer, because I'm going to cover these up right now. Let's see. Cover them up with a lid. Okay, sublimation is taking place. It's going to be right here. Don't know where I should put this so you guys can see. Okay, turn my computer. Can you see the 3 containers there? Right here. Okay, I'm going to leave it there for a second. Well, for more than a second. So what's happening to the dry ice right now is that it's going through the process known as sublimation. Sublimation means that it's going to go from a solid directly into a gas. Now we have to give it a couple of minutes, and I'm going to talk to you guys, and you can answer in the chat at the same time. Oh! Scared me. Oh, goodness. Anything else going to happen? I don't want to get too close. Why don't I want to get too close? Woo! Okay. Yeah, it'll pop off in my face. Tell me why it popped off like that. Tell me what happened. The pressure from what? Be a little bit more specific, Nathan. The pressure from what? The gas. Yeah. So when the dry ice is in the container and it's going through the process known as sublimation, what happens is that gas builds up in the container. And remember that gas molecules want to get out of the tightly enclosed space that it's in and move to an area of less concentration, right? So it wants to, I don't know where the other lid went. It wants to get out and move about. Okay, the next thing I'm going to show you. We talked about, by the way, that always scares the living daylights out of me. We already talked about bubbles, right? So here I have regular old bubbles. And I don't know, did you see them? Okay. What I'm going to do is I'm going to take this container, my very large beaker, and I'm going to take some dry ice, and I'm going to put it down in the bottom of the beaker. Let's see. And what's going to happen, hopefully, that dry ice is still giving off gas. So now I've taken my beaker and I've put the dry ice in it. Okay, it's down in the bottom of the beaker. And I have this cardboard box, empty cardboard box, just resting on it. Okay. I don't want to cover it tightly because remember, dry ice builds up that gas. The gas is going to cause things to explode. This is why you don't want to put things into your, you don't want to put dry ice into your freezer. Because if you put dry ice in your freezer or your refrigerator, right, the gas is going to build up in there and it could cause the door to pop off, right? So you have to be really careful when you're working with dry ice. Now, the reason why I have it covered with the cardboard box is because I want to keep the dry ice, the gas, the carbon dioxide gas, I'd like to keep that in the container, right, this beaker, as best as I can, because cold air is more dense, so it's going to hang out lower into the container, right, our beaker. Now, if I take bubbles and I blow bubbles, which I just did earlier, those bubbles are just going to fall down and pop, right? They don't have helium in them. They're just regular old bubbles. Technically, what should happen, or what do you think will happen if I blow the bubbles over the canister? Braden?
The bubbles will float on top of the carbon dioxide gas at the bottom of the canister.
It should. That's my hypothesis. That's what we're going to test, right? So we're just letting the amount of carbon dioxide gas build up. Oh, here's the other lid. You can get dry ice. I went and bought some this morning at Smart and Final. Just so you know, it's about $20 for a brick of dry ice. And I shared it with Mr. Roth because he's doing this today also. But yeah, we're going to let that dry ice kind of sublimate in this container, which the bottom of it is getting really cold. It feels good. And we're going to let that carbon dioxide gas build up in there right now. Nathan did this in 3rd grade. That's great. It's filled with gas and yep, it pops off because of the pressure. Yeah, Alexis, I got scared too. You should have seen my cats. They ran. There was something that somebody asked. Yes, it is poisonous gas. Somebody asked about the container, right? Okay. Do they have to be cylinder or can it be a square plastic box or a different shape? So that's a great question, Peyton. So the most important thing about it is that the lid has to be able to pop off. It can't be screw lid, but they do, you know, Rubbermaid makes these really small containers and so does Tupperware and stuff. If you just use a really small one, in that size container, you would just, you know, take maybe an ice cube size piece of the dry ice, cover it with the lid because the lid just pops on and that should work. Yeah, as long as it has a pop on lid, it doesn't matter the shape of it at all. Okay, so let's see what's going to happen here with my bubbles. I'm going to put this, can you see it? You can see it, good. Okay. See it? Oh, look at that. Can you see that one? I don't know if you can see it. Hold on, I'm gonna disconnect you guys. Can you see that one bubble floating in there? No? Ah, it popped. Okay, let's see if I can get another one. Get this closer. I don't know if you're gonna be able to see the bubbles because they're clear. Yeah, and I have to cover it again and let the gas build up again. I don't know if you're going to be able to see the bubbles because they're clear. I would suggest trying to do this at home because, oh, Makai, you saw it, cool. Because the bubbles are difficult to see because they are clear, right? It's going to be more difficult to see the ones that are suspended in the air, but they're going to float in the container. They are not going to, unless they hit the side of the container, you know, they're not going to sink because the cold air is more dense, so it's down below. So it's kind of like a little magic trick for you guys. If you are using dry ice, please use it with carbon monoxide is poisonous. Yes, Braden, thank you for clarifying that. You don't want to eat dry ice because you can get freezer burn. You're right, it's not poisonous. If you are touching the dry ice, you don't want to eat the dry ice. You don't want it to touch your hands or any part of your skin because you will get frostbite, right? So it's like keeping your hands in an embankment of snow for a long period of time, and then you get frostbite. Touching dry ice will do that to you as well. Carbon monoxide is the gas that is poisonous. Carbon dioxide, we give off carbon dioxide. Carbon dioxide is the gas that's given off when the dry ice sublimates, okay? So you'll notice, I mean, this dry ice has been sitting in this jar for a while now. Ooh, that's cold. And there's no liquid in here whatsoever. It's just ice. There's absolutely no liquid in there because it's sublimating. It's going directly into the gas phase. If you get dry ice, please have a parent with you. I don't know if they'll let you buy dry ice from Smart and Final. They may want to have a parent with you. Chase says no, they won't, because then you might do something like this and hurt yourself, and that would kind of be stupid, right? Okay, so let's try to blow some more bubbles. Thank you, Maria. So can frostbite kill you? You can die from injuries from frostbite. I don't know if I want to say that frostbite can kill you itself. It's like a secondary. So yeah, does that make sense? If you get like if somebody gets frostbite on their fingertips, that's, you know, not that it's okay, but they're going to survive. However, if you are left out in the elements for a long period of time and you get frostbite on different parts of your body, that could lead to infections and other issues. So yes, kind of. Yes, the elements will most likely kill you depending on how long you are out in the elements for. Okay, I'm gonna try bubbles one more time. Hopefully you'll be able to see it. I'm gonna turn this. Yeah, I'm gonna go right here because I want it to be closer for you guys. And hopefully a little bubble. Oh, can't get bubbles down there. See, usually I do this with a fish tank, and it's a lot easier with a fish tank because it's a bigger space and it won't hit the edge of the container. Yeah, it's not going to work. It worked earlier. I'm sorry for those of you that didn't see it, but that gives you a reason to try to experiment at home with this if your parents will let you. Like I said, if you have a bigger space to put the dry ice in, like a fish tank, an empty fish tank, then the bubbles won't explode on the side of the container that your dry ice is in. My bubbles, they exploded because of the container that it's in. When I have a larger container, when we use a fish tank at school, it works a little bit better. The other thing that I've done with my bubbles is that This is a regular container of bubbles, but I've added something called glycerin to it. Glycerin or corn syrup can also be used. Those make the bubbles thicker so they don't pop as easily. Okay, so I'd like you guys, if you guys are all good, tell me, give me a thumbs up if you're okay. All right, cool. Take out a device or open up to a page because we are about to Kahoot, unless somebody has anything they want to add into the chat. Thank you, Oliver, for the thumbs up. We're good. Okay, I'm going to turn off the chat. Thank you, Peyton. I'm going to turn off the chat so I can share my screen and I can get you guys onto Kahoot. And your code is 5396941. You're at kahoot.it. Sign in with your first name, please. Thank you, Sophia. Excellent, excellent. There's only 12 questions to today's Kahoot. Excellent. Keep signing in, guys. Thank you, Chase, Aubrey. Tajay, Oliver. Oh, Porty, you usually put Porty on there, not Alejandro. Naima. Okay. Bryn, I don't see you on there. Where's everyone else? Braden, thank you. Awesome. Abraham, Alexis, good. Daniel, your name is so much fun to say. It's like Daniel Antonico. It just rolls off my tongue. Audrina, awesome. All right, I have 19 players so far. I have more people in the room. Drew, thank you, Drew. Makai. 21 people playing. I will give you guys another minute to get on. Okay, are we ready? Let's go. Question number 1 as we go. This is about matter. We all matter. What has its own shape and its own volume? A solid, a liquid, or a gas? Okay, so a solid has its own shape. It's not going to take the shape of anything else. If I have a liquid and I pour my liquid into this film canister, it's going to take the shape of the film canister. If I pour my liquid into a box, it's going to take the shape of a box, right? And the gas will not take shape of anything. It just wants to get out of its own, you know, of its own way, right? So the answer is a solid. Good job. Let's see. Keep going. Question 2. What does not have its own shape or volume, and its particles are very far apart? I just said it. Waiting on one person. Woo, somebody else joined. Awesome. Perfect, a gas. Yeah, remember those gas molecules, man. They just want to bounce and get into an area that is least restrictive for them. They want to be out and moving around. A liquid will take the shape of any vessel that you put it in. But the difference between the gas and the liquid as far as this statement is that the gas molecules are very far apart from one another. Okay, a little movement. Question 3. Which has a definite volume, but not its own shape? It'll take the shape of something else that it's put into. And we use the volume, we measure the volume with a graduated cylinder for this, right? It is a liquid. Great job, guys. Okay, no movement. All right, let's see what's next. Number 4. What is the basic building block of matter? You guys looked at it. We've written some notes on it already. We've talked about different parts of it. What is all matter made up of? Elements. Very good. Yes, absolutely. So humans, right? Or yeah, well, mostly carbon, nitrogen, oxygen, hydrogen, but everything is made up of elements and atoms. Ooh, lots of movement there. Okay. Question 5. This takes place when particles leave a liquid and become a gas. You're going from liquid to gas. What is that called? Good, evaporation. And on the poster that you're going to be creating, I gave you a sample and they have a word called vaporization on it, which is the same thing as evaporation, just in case if you were wondering. Oh, a little movement there. Porty's on his way up. This occurs when a gas turns into a liquid. Another example of condensation is if you walk out of your house early in the morning and you feel either the grass or like I have furniture in my backyard, and if I run my hands over it, it feels moist. That's because condensation is taking place from the vapor in the air that is touching whatever it is outside that you can feel, like the grass. And that's how you get dew on the grass. DEW, dew on the grass in the morning, right? Condensation. A little movement. This takes place when a solid changes directly to a gas, just like our dry ice. Yes, good job, guys. No movement. Question 8. Anything that takes up space, what do we call it? Matter. Matter takes up space, absolutely. No movement there again. Let's try 9. The universal solvent. Oh gosh, I didn't tell you about this. Take a guess. We didn't talk about solutes and solvents yet. I just didn't take this one off of the Kahoot. My apologies. Universal solvent. There are solutes and solvents. Solvent is whatever the solute is dissolved in. So let's say I have Kool-Aid, right? And I have my water. My water is my solvent. The solute, what's going into the water to dissolve, is the Kool-Aid powder. So you have a solute and a solvent. Movement. Oh, nice. Okay. Question 10. There are 3 states of matter. What are they? Yes, great job. Question 11. What's an example of condensation? See if you were listening to me. I just said it, guys. The dew on a grass, right? On the grass. So I don't ever really, I don't step on grass really. I don't really like the feeling of it, but I do know that condensation is taking place because when I go outside and I feel my furniture in the morning, it is moist or damp, and that's condensation. Good. Okay, last question. What two processes need heat? I talked about it earlier. What two processes need heat? What do I add heat to? So we said earlier that if I have an ice cube and I add thermal energy to it, which is heat, it becomes a liquid. That process is called melting. Then if I take that liquid and I add some more thermal energy to it or heat, that process is known as evaporation because you're going from your liquid to a gas. Okay, let's see where we stand. Drum roll. In third place, we have Mr. Hen. In second place, we have Mr. Porty. In first place, we have, drum roll, Mr. Martinez. And who are our runner-ups? Emily and Maria. Great job, guys. Great job. That one question about solutes and solvents threw you guys off a little bit. I'm going to stop sharing here. Turn on the chat. Okay, so how do you guys feel about, turn off the recording also.